The amperage draw of a typical computer workstation is a multifaceted issue contingent on several variables. These include the specific components integrated within the workstation, the peripherals connected to it, and the operational intensity of each device. As a general estimation, a single computer workstation, incorporating the computer itself, a monitor, a keyboard, a mouse, and other common peripherals, typically draws between 2 and 4 amps. However, this range is not absolute and can fluctuate significantly based on the factors mentioned earlier. When designing electrical systems for computer workstations, it is crucial to account for the potential of multiple workstations being connected to a single circuit. This involves calculating the cumulative amperage draw to ensure that the circuit's capacity is not exceeded, which could lead to trip breakers or, in more severe cases, electrical hazard. A standard 1-pole 20 amp circuit, as you mentioned in your design, has a capacity of 20 amps. However, electrical codes typically recommend not loading a circuit to its maximum capacity continuously. A common practice is to limit the continuous load to 80% of the circuit's rating. This deterring factor is implemented to prevent overheating and potential safety issues. In the case of a 20 amp circuit, the maximum continuous load should ideally not exceed 16 amps, which is 80% of 20 amps. Considering the typical amperage draw of a computer workstation, if each workstation draws between 2 and 4 amps, you can estimate the number of workstations that can be safely connected to a single 20 amp circuit. With the 80% deterring factor, the available amperage for workstations is 16 amps. If each workstation draws 2 amps, you could theoretically connect up to 8 workstations to the circuit. If each workstation draws 4 amps, you could connect up to 4 workstations. However, these are theoretical maximums, and it is always wise to incorporate a safety margin. In real-world scenarios, it is often observed that more workstations are connected to a single circuit than what the theoretical calculations suggest. This is often because not all workstations operate at maximum capacity simultaneously. Users may be engaged in tasks that do not require significant processing power, such as web processing or web browsing, which reduces the amperage draw. Additionally, modern power supplies and electronic devices are often designed to be energy efficient, drawing only the power they need at any given time. However, relying solely on the assumption that workstations will not operate at maximum capacity is risky. It is essential to consider the potential for peak loads, such as when multiple users are running demanding applications, performing video editing, or engaging in other resource-intensive tasks. Overloading a circuit can have several negative consequences. Firstly, it can cause the circuit breaker to trip, interrupting power to the workstations and potentially disrupting work. Secondly, prolonged overloading can lead to overheating of the wiring, which can damage the insulation and increase the risk of electrical fires. Thirdly, frequent tripping of the circuit breaker can damage the breaker itself, reducing its effectiveness and potentially leading to a more serious electrical fault. To mitigate the risks associated with overloading, it is crucial to adhere to manufacturers' recommendations for the maximum number of devices that can be connected to a single circuit. These recommendations are typically based on the device's rated amperage draw and are designed to ensure the safe and reliable operation of the electrical system. Additionally, it is advisable to distribute the workstations across multiple circuits to reduce the load on any single circuit. This can be achieved by carefully planning the layout of the workstations and the placement of electrical outlets. In your specific case, where you have designed for 2 to 3 workstations per 1-pole 20 amp circuit, you have provided a significant safety margin. This design approach allows for a comfortable buffer to accommodate fluctuations in amperage draw and reduces the risk of overloading the circuit. However, it is still important to monitor the circuit load and ensure that the total amperage draw does not exceed the recommended limit. To accurately determine the actual amperage draw of a computer workstation, you can use a clamp meter. A clamp meter is an electrical testing device that can measure the current flowing through a wire without having to make direct contact with the wire. This makes it a safe and convenient tool for measuring amperage in live circuits. To use a clamp meter, simply clamp the meter around the power cord of the computer workstation. The meter will display the amperage draw of the workstation. By measuring the amperage draw of several workstations under different operating conditions, you can get a better understanding of their power consumption patterns. This information can then be used to optimize the electrical system design and ensure that it is adequate for the intended use. In addition to considering the amperage draw of the computer workstations, it is also important to consider the other electrical loads that may be connected to the same circuit. These may include lighting fixtures, printers, copiers, and other office equipment. The cumulative amperage draw of all of these devices must be taken into account when determining the overall load in the circuit. Another factor to consider is the power factor of the computer workstations and other electrical devices. Power factor is a measure of how efficiently an electrical device uses electricity. A power factor of 1 indicates that the device is using electricity very efficiently, while a power factor of less than 1 indicates that the device is using electricity less efficiently. Devices with a low power factor draw more current than devices with a high power factor for the same amount of power. This can increase the load on the electrical circuit and potentially lead to overloading. To improve the power factor of an electrical system, power factor correction capacitors can be installed. These capacitors compensate for the reactive power drawn by devices with lower power factors, reducing the overall current draw and improving the efficiency of the system. Regarding isolated grounding type receptacles, these are often used in computer workstations to reduce electrical noise and improve the reliability of the equipment. Isolated grounding receptacles have a separate grounding conductor that is isolated from the building's main grounding system. This helps to prevent ground loops, which can cause electrical noise and interfere with the operation of sensitive electronic equipment. In summary, the amperage draw of a typical computer workstation is a variable factor that depends on the specific components, peripherals, and operating conditions. When designing electrical systems for computer workstations, it is crucial to consider the potential for multiple workstations being connected to a single circuit and to account for the cumulative amperage draw. It is also important to adhere to manufacturers' recommendations, distribute the workstations across multiple circuits, and monitor the circuit load to ensure that it does not exceed the recommended limit. The steps to take are as follows. Firstly, determine the typical amperage draw of a computer workstation, considering its components and peripherals. Secondly, calculate the total amperage draw of all devices connected to the circuit, including workstations, lighting, and other equipment. Thirdly, ensure that the total amperage draw does not exceed 80% of the circuit's rating to prevent overloading. Fourthly, monitor the circuit load using a clamp meter to identify potential overloads. Fifthly, distribute workstations across multiple circuits to reduce the load on any single circuit. Sixthly, consider the power factor of the electrical devices and implement power factor correction if necessary. Seventhly, use isolated grounding receptacles to reduce electrical noise and improve equipment reliability. By following these guidelines, you can design a safe and reliable electrical system for computer workstations. Now let's talk about some more specific aspects related to computer workstation amperage. The 2 to 4 amps range is a broad generalization. A basic workstation used for word processing and email might draw closer to the 2 amps end of the spectrum, especially if it uses an energy-efficient monitor and has minimal peripherals. A high-end workstation used for graphic design, video editing, or gaming could easily exceed 4 amps, especially when running demanding applications that put a heavy load on the processor, graphics card, and storage devices. The hard drive you mentioned drawing 6.5 amps seems unusually high for a modern hard drive. It's possible that this rating is for the inrush current, which is the brief surge of current that occurs when the drive is first powered on. The continuous running current would likely be much lower. The 1 amp rating for the monitor is more typical, but it depends on the size and type of monitor. A large, high-resolution monitor will draw more power than a smaller, lower-resolution monitor. LED backlit monitors are generally more energy efficient than older LCD monitors. The fact that you've seen 6 to 7 workstations on a single circuit without tripping the breaker suggests that the workstations are not consistently drawing their maximum rated amperage. However, this is not a reliable indicator of the circuit's capacity. It's possible that the circuit is close to its limit, and a sudden increase in load could cause it to trip. Also, continuous operation near the circuit's limit can shorten the lifespan of the breaker and increase the risk of overheating. When designing electrical circuits for computer workstations, it's best to err on the side of caution and provide ample capacity. This will ensure that the circuit can handle peak loads without tripping and will reduce the risk of electrical problems. The NEC, National Electrical Code, provides guidelines for electrical installations, including requirements for circuit sizing and overcurrent protection. While the NEC does not specify the exact number of workstations that can be connected to a single circuit, it does provide rules for calculating the load on a circuit and for selecting the appropriate size breaker. NEC Section 220.14 provides information on general lighting loads. NEC Section 220.18 provides information on receptacle loads. NEC Article 310 provides guidelines for conductor ampacity. When calculating the load on a circuit, it's important to consider all of the devices that will be connected to the circuit, not just the computer workstations. This includes lighting, printers, and other office equipment. It's also important to consider the potential for future expansion. If you anticipate adding more workstations or equipment in the future, it's best to design the electrical system with enough capacity to accommodate the increased load. Using isolated grounding receptacles is a good practice for computer workstations, as it can help to reduce electrical noise and improve equipment reliability. However, it's important to ensure that the isolated grounding system is properly installed and grounded. The isolated ground conductor should be run directly back to the main grounding electrode system and should not be connected to any other grounding conductors along the way. If the isolated grounding system is not properly installed, it can actually increase the risk of electrical noise and ground loops. It is always best to consult with a qualified electrician when designing or modifying electrical systems. An electrician can help you to calculate the load on a circuit, select the appropriate size breaker, and ensure that the electrical system is installed in accordance with the NEC and other applicable codes. Furthermore, consider using power distribution units (PDUs) with built-in current monitoring. These devices can provide real-time information about the amperage draw of each outlet, allowing you to identify potential overloads before they cause problems. Some PDU also have remote monitoring capabilities, allowing you to track power consumption from a central location. Energy-efficient power supplies are also very important for computer workstations. Look for power supplies that are 80+ certified. This certification indicates that the power supply meets certain energy efficiency standards. 80+ certified power supplies are more efficient at converting alternating current power to direct current power, which reduces energy waste and lowers the overall amperage draw of the workstation. Another thing to consider is the use of uninterruptible power supplies, UPSs. A UPS provides battery backup power in the event of a power outage. This can help to prevent data loss and equipment damage. UPS also typically provides surge protection, which can protect the workstation from voltage spikes. When selecting a UPS, it's important to choose one that is appropriately sized for the workstation. The UPS should have enough capacity to power the workstation for a reasonable amount of time during a power outage. The runtime of a UPS depends on the load connected to it and the capacity of the battery. Now let's address the design you mentioned, utilizing 2 to 3 isolated grounding type receptacles per 1-pole 20 amp circuit. Firstly, this is a conservative design, providing a good safety margin. If you assume each workstation draws a maximum of 4 amps, then 3 workstations would draw a total of 12 amps, which is well below the 16 amps maximum continuous load for a 20 amp circuit. Secondly, this design provides flexibility. If one of the receptacles fails, the other receptacles can still be used to power the workstations. Thirdly, this design allows for future expansion. If you need to add more workstations in the future, you can simply add another circuit. However, there are also some potential drawbacks to this design. Firstly, it can be more expensive than using fewer circuits. Secondly, it can require more space in the electrical panel. Overall, the design of using 2 to 3 isolated grounding type receptacles per 1-pole 20 amp circuit is a good one, providing a good balance of safety, flexibility, and cost. However, it's important to carefully consider the specific needs of your application and to consult with a qualified electrician to ensure that the electrical system is properly designed and installed. Also, consider the ambient temperature where the workstations are located. High temperatures can reduce the ampacity of conductors, so it's important to factor this into the calculations. NEC Table 310.15 provides ampacity correction factors for different temperatures. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It's important to be familiar with these codes and regulations and to ensure that the electrical system is installed in accordance with them. Consider using a power quality meter to monitor the electrical system. A power quality meter can measure voltage, current, power factor, and other electrical parameters. This information can be used to identify potential problems with the electrical system, such as voltage sags, voltage swells, and harmonics. Harmonics are distortions in the voltage and current waveforms that can be caused by nonlinear loads, such as electronic devices. Harmonics can cause overheating of electrical equipment and can interfere with the operation of sensitive electronic equipment. Power quality meters can also be used to troubleshoot electrical problems. For example, if a circuit breaker is tripping frequently, a power quality meter can be used to identify the cause of the tripper. By analyzing the voltage and current waveforms, it may be possible to determine whether the tripping is caused by an overload, a short circuit, or a ground fault. In conclusion, designing electrical systems for computer workstations requires careful consideration of a variety of factors, including the amperage draw of the workstations, the load on the circuit, the power factor, the ambient temperature, and applicable codes and regulations. By following the guidelines outlined above and consulting with a qualified electrician, you can design a safe and reliable electrical system that meets the needs of your application. Remember that ongoing monitoring and maintenance are also crucial to ensure the continued safe and efficient operation of the electrical system. Regular inspections can help identify potential problems before they become serious, and prompt repairs can prevent costly downtime and safety hazards.